Okay, so as it says, my name's Dave Hofer. Good thing, because otherwise I'd have to redo all my slides here. But I'm an application engineer with Fisher Unitech, and tonight I'm going to talk about convergence or design collaborations, however you want to say it. Actually, the gentleman from Desai gave me a pretty good intro there. What I'm going to do is I'm going to kind of walk you through a development process, a little bit different than probably what you're used to seeing with the electrical application, because I'm not going to do like a control enclosure with relays and motors and that kind of stuff. I'm going to do something a little more embedded. So we're going to do some electronic content, and then I'm going to show you a new design tool called SolidWorks Pcb. It was announced at SolidWorks World. We'll talk about that a little bit in a second. And then we'll look at how SolidWorks Pcb integrates into SolidWorks. We'll do a little bit of system design in SolidWorks Electrical, and then we'll sort of jump back into SolidWorks and put it all together. So just a little bit about me. My background is mainly electrical and electronic product design, and in particular printed circuit boards and electrical controls. So some of the things I've done, I've brought to market a couple different generations of PLCs with motion control in them. I did high-speed imaging systems, some people call them cameras, semiconductor failure analysis tools, and I worked on a mirror system for a satellite application for one of your favorite three-letter acronym companies in Washington area, if you know what I mean. All right, so what I want to do is just illustrate mainly how to integrate these three distinct design domains. So we're going to look at the printed circuit board design, we'll look at the system electrical design, and the mechanical, and sort of how to put them all together to produce a finished product. And don't worry, I'm not going to do slides all night. We'll get to the software here in a minute. And actually, in order to do this, I'm going to be running three separate pieces of software here. I'm going to run SolidWorks, SolidWorks Electrical, and this new product called SolidWorks Pcb, previously known as PCB Works, which is from a company called Altium, if you're not familiar with them. And if you go and look on our electrical product portfolio, you'll see the SolidWorks Pcb there as they continue expanding that whole product line. So you'll see probably this year a lot more in the electrical area from SolidWorks. But what I'm going to do is I put this design flow together, and this is kind of like what I call a traditional design flow. The way the products interconnect, you don't have to follow a flow like this. You can pretty much come up with any design flow you want, but this is the one I'm going to use tonight. So we're actually going to start in SolidWorks and define the board outline, and then we're going to push that over to PCB Works, and then we'll take a look at how those two things interface with the collaboration server, and we'll do some system wiring in SolidWorks Electrical. We'll jump back into SolidWorks to do the integration, and then we'll follow it up with looking at how design revisions work between SolidWorks and SolidWorks PCB, and then how we can get some of the copper information out of the circuit board for doing like thermal analysis and stuff like that. So this is kind of what I call a traditional PCB development flow, and I've actually been guilty of something a lot like this in the past, and if you work with PCB designers, you may actually recognize this a little bit. But generally speaking, not always, but generally, the look and feel is defined in the mechanical space. We develop the mechanical parts, the enclosure, and then that's where we define the board dimensions. So then we have to transmit this information to the PCB designer somehow. And the way it's typically done is the mechanical designer will generate a neutral file like a DXF or a DWG or EIEIO, and either email it or put it up on some shared storage device somewhere. Then the PCB designer has to take it, massage the data, you know, jump up and down, swear a lot, and eventually get it into the PCB tool where he can do his component layout and stuff like that. And then at some point in time, we have to update the mechanical space, so you have to reverse the whole thing. And then this goes on, you know, back and forth until you end up with something that looks a lot like this, which is really not what you want. So what we're going to do is take a look at a little bit more of a desired flow here. One in which what we'd like to do is start on the mechanical side, creating the enclosure, defining our mechanical bits, and at the same time the PCB developer can be creating the schematic, doing circuit simulation, stuff like that, until we get the board shape defined where we can just push it across the table basically over to the mechanical space. Over to the PCB space where we can do our initial component placement, push it back across the table into SolidWorks where we can check placement, we can do our interference checking, edit the assembly if we need to, and then push it back across the table so we can take it now and route it, and then the workflow will carry on from there. So here's the system, and it's a simple example here, but basically we've got our AC power coming in, we've got our power supply, which feeds our main controller board, and there's secondary power supplies developed on there which are fed out to the rest of the system. And then we also are talking to our stepper motor, which has a stepper motor driver board, and that's actually where we're going to start our design here tonight. And the way we're going to do that, like I said, we're going to define the board shape in SolidWorks using the motor frame as a guide, and then we're going to transfer that over to SolidWorks Pcb. And the way we're going to do that is we're going to use these collaboration panels that we have in the applications. Once we do that, we're going to place the components in SolidWorks Pcb, and then we're going to push it back over to SolidWorks so we can do our interference checking. And when we do that, we're going to create native SolidWorks SLD PRT components when we do that. But we don't, if we have like 150 bypass caps, for example, we're not going to create 150 SLD PRT files. We're only going to create one for each unique component, which is a little bit different than what happens with a lot of these neutral file translators. So something to keep in mind.
When you say interference, is it mechanical or
yes,
electrical?
Yep, mechanical interference, yep. So after we do the interference checks, then we can, you know, go ahead and start routing the PCB without being too worried about, you know, finding out some surprises when we get it back from prototyping. And this is where you can save a huge amount of time, because you want to make sure you get all those checks done before you do the routing, because if you have to do that after you've routed the board, then that's when you can really lose a lot of time. So let's go ahead and take a look at how we can do that. So I'm going to start right here in SolidWorks, and you can see it's a simple little project, but we've got our AC input here, got our power supply, we've got some bracketry to bolt it all to the rest of the assembly, and then we've got our main controller board here, and then here we have our stepper motor, and that's actually where we're going to start things out, because this is where we want to define our board shape here. And the way we're going to do that is we're going to click over here. You can see we've got this collaboration panel available to us. What we're going to do is we're just going to go ahead and create a new board assembly. And what we're going to do is we're going to link the assembly to a project that's already been created in PCBWorks or SolidWorks Pcb. So we're going to just go ahead and click OK, and then we just have to save the assembly as soon as my hard drive wakes up. And then what this does is it just builds us a default PCB outline just to sort of start with. So what we're going to do is we're just going to make this kind of look like a PCB here for starters. And then we're going to hop back over in here, and we're just going to place our PCB in our assembly here. And then we're just going to go ahead and mate it here. Then what we're going to do is we're just going to go ahead and edit our outline here, and we're actually going to just get rid of that, right? Because what we want to do is we want to use this outline of the motor here to create our board outline. We're going to get rid of this bump out for the connector here, like so. And then while we're at it, we're just going to go ahead and we're going to create some mounting holes here. And now what you would normally want to do is go ahead and convert all these mounting holes and extrude them all in one step here, but that would be, you would be doing a bad thing if you did that, because one of the restrictions with the collaborative server here is you have to create all of these features as separate cut extrude features. You can't do them all at once. You can't do a pattern array. Really the only way to do it is to create them all individually. So that's really the only caveat there. So once we get all that defined, we're just going to hop over here in our circuit board assembly, and we're going to open up the collaboration panel again. And we're just going to push this over to SolidWorks Pcb. Okay, now I'm going to bring up SolidWorks Pcb, and because we only got a limited time here, I can't go through the whole thing, but basically this is a full-featured PCB tool here. We've got a schematic tool. We can do circuit simulation, things of that nature. And then we've also got a PC board editing tool, and you can see here we've got the same sort of default board outline like we started out with in SolidWorks. But I'm going to go to the collaboration panel here, and you can see we've got a message that says some changes have been detected. So we're going to look at the changes. We're just going to preview them here. And we can see, and I can already see, I need to flip this around when we go back into SolidWorks, but we can see the board outlines created, and we've got just one of the mounting holes here right now. So I'm going to go ahead and accept those. And that'll bring our board shape in here. So then what we're going to do is we're going to do what's called a compile here. What that does is just run a DRC check to make sure we have everything hooked up right. And if we would have gotten any errors, this message panel would have popped out with errors in them. You can see there's some warnings here, but those aren't show breakers. So we're going to go ahead and basically push all this information over to the PCB editor now. So we're going to update the PCB with all the content that we have in our schematic tool here. And when we do that, you can see it throws all the components over here on the side of the board. And so now we can go ahead and place them. Now again, this is a simple design. And if you were doing this for real, you'd take a lot more care in where you're placing things. But I'm just going to go ahead and throw these things on there. Grab these last caps here and we'll put them right here. And then the thing to note here is this is only a 2-layer board. Matter of fact, we can go to the layer stack manager here. You can see we've just got a top and bottom layer. Now this will support up to 32 layers, but this is just a pretty simple design. And you can see we've got the top layer defined as red and the bottom layer defined as blue. And the reason I want to show you that is if we wanted to, for example, get these bypass caps close to some power rails here, if we bring this over, you can see this guy changes green, and that's the universal sign in SolidWorks PCB that you have that you're violating some design rules here. So what we can do is we can just go ahead and flip that over on the bottom so we don't have that problem. So we're just going to take these guys and put them all on the bottom like so. And then you'll also notice these components have these little grayed out outlines in them. What that means is that there's actually 3D models attached to all these components, and we can visualize it if we go into the 3D mode here. You can see all the components there, and we can check those caps that we put on the back of the board, make sure they're where we think they should be. And then when you get all that set, what you're going to do is you're just going to push this back across, say here is the component layout, and we're going to push that into the collaborative server. Takes a couple seconds, and then once we get that all squared away, we'll go back into our board assembly here, and we'll access the collaborative panel again. We get into the right, there we go, into our assembly there. And you can see again we got a little message here that says there's changes, so we're going to go ahead and bring those in, and I'm just going to go ahead and check them all. And you can see the feature manager tree over here is populating with those components. Alright, once it's all done, we can see we've got all that, and we've got all the reference designators here, so we know what's what, R4, R1, R3, and we've got all native SolidWorks parts here. So if we go back over to the assembly, and like I said, I've got this thing, I put it in the wrong way here, so I'm going to go ahead and get rid of this mate. And we'll go ahead and flip this guy around here, like so. And so now we've got our board pretty much all defined there. All right, let's hop back here so we keep on track. So once we get the PC board design done, now we've got to basically finish up our electrical system design, and we're going to start in the line diagram, and then we're going to jump over onto the schematic where we'll finish up doing our detailed connection points. And then we'll jump back over into SolidWorks, and we'll place the components using the electrical manager tab. And then we'll go ahead and place the connectors there where they need to mate up on the circuit board. And thing to note for you mechanical people, you definitely want to put mate references on your parts so your electrical guys don't hurt themselves trying to put these things into assemblies, because it's been known to happen. So then once we get all that done, we'll go ahead and route the wires and cables using the route commands in SolidWorks. And then, of course, we'll have length information associated to all the wires and cables, and then we can extract that when we run our reports, so we can have accurate material lists. Let's go ahead and take a look at that. And I'm going to go ahead and open up the line diagram and the schematic here. And this is all actually an electrical project, okay, so that we've been working on here. And you can see we've got to add our stepper motor controller board and all that. So I'm going to go over here onto the side panel, and I'm going to grab a stepper motor board, and I'll put it in here. And I'm going to go ahead and associate that to a part number that I already have for it as soon as my hard drive wakes up. Here we go. And then we need to add the connectors here to attach to our cables. So I'm going to put one over here to go to the main controller board. And I'm going to put one over on this side to go to the stepper motor. And then once we have that, we just really need to connect them up.
What version of SolidWorks is this?
This is 2016.
Does the 2015 version have the same, your library on the right where
It's got the same panels, but they're over on the left-hand side. Yeah, because, and I'll show you that after we're done here. Remind me to show you because there's some other features here associated with that.
Okay.
Yeah.
What are you guys using, Phil?
Right now I'm trying to integrate SolidWorks Electrical. Right now we use DriveSite. Everything is kind of,
Yeah.
so we're trying to merge and get this going.
Gotcha.
It's just taking a little longer.
So then I'm just going to reserve these cables here. I've got some cables in here in my design, and so I've got a couple of 6 conductor core cables here that I'm going to use for these guys, and I'm just going to associate those. And then once we get those all set, we can hop over into our schematic and add the detailed connection information. So I'm going to add those connectors over here as well, but I'm not going to use the symbol palette. I'm going to use the dynamic connector tool here, and I'm going to use the component information to actually build the number of terminals that I need sort of on the fly. So it's a kind of a nice tool. And so you don't have to use symbols all the time if you don't want to. I'll just set that in there. I'll do the same thing for S5 here. And then I'm just going to turn off some of these annoying description attributes here to get them out of the way. And then we just need to draw our conductor cores over there. And I'm going to use the motor wire style, oddly enough. And then I'm going to give it 6. The number of lines is 6 because it's a 6-position connector. And I'll do the same for these guys here. And then once we get those done, just go ahead and number our wires. So we've got those numbered. And then I'm just going to associate those cable cores to these cables that we already have identified here. Let me open this up a little bit. And then we'll do the same thing over here to this guy. Man, that's a loud clock. Alright, now the last thing we need to do here is I've got these 4 connectors and the wires that go between them. I'm going to actually make a harness out of this. So I'm just going to select these, and I'm going to add this to this harness I have here, H1. And we should be good to go there. So let's hop back over into SolidWorks. And we're going to go ahead and place our connectors here for this. So we're going to swing around here, and we're going to use the component electrical manager over here. And I'm actually going to hide all of the components that are already placed because I just want to see the ones that I need to place. So we'll go ahead and put S4 in here. We'll add S5. And then we're going to swing around here. And then we're going to go ahead and use some of the electrical commands on the 3D tab here. We'll start out with our harness. We'll get that guy going. And then once that's done, we're going to go ahead and route our cables. just have two of them, so it shouldn't be too long. Here's a good place where if you have any really good jokes, you might want to throw them in.
I have a question though. Are these you're jumping to these different like programs or modules? Like if you buy the electrical package, do you get all these? Do you have to buy them? Are they a la carte or how does that work?
Well, that's a little bit of a discussion there, so hold that thought.
Okay, that's fine.
Let me get through this,
That's
and then because that's a good question actually,
250 grand and it's all.
and that's all you need,
I
right?
had 250 grand in
And
this
you
beach thing.
make the check out to David Hofer, right? And then the last thing we're going to do is just route our wires here. And the wires are going to take a little bit longer because what happens is it creates a wire route assembly for each different wire style. And because I happen to have, for the power supply, AC input and the power supply going up here, I happen to use actually all 5 different wire styles. So it's actually going to create 5 separate route assemblies. So if these were all one wire style, it would take a lot less time to route, I guess is what I'm trying to say. Trap for young players. Okay, last wire. All right, so now we've got all our cables and everything routed. Let's take a look. Looks like everything's pretty good there. Let's go ahead and hop back over into electrical, and then we can go ahead and look at our reports. And you can see we've got length information now on our wires, which is always good. And we've got cable and length information on our cables, at least the ones that we've used. We've got a couple of them we haven't used yet. So we're just going to go ahead and I'll just generate these ones here that I selected. And they'll populate over here in the Documents Manager. And then what I like to do is I like to make these folders in here where I can just throw everything in, just sort of keeps everything organized. And we can see we've got our bill of materials, got our list of wires that have length information on them now, so we know how long everything needs to be. Same with our cables. But you can see we've got W1 and W5 we didn't really use, so they don't have any length on them. So something to note, if it's in the design, it's going to be in the reports. And if it's not in the design, it won't show up in the report. So everything's linked together. All right. So let's jump back over here. And so we really only have 2 more things to consider. Design modifications, and we'll look at how to get the copper over to do thermal analysis. So one of the things here is something that never happens in real life, right? You never have this kind of stuff happen. Design changes or surprises that come up. And so what we can do is we can easily make these modifications now and just push them back over to PCB Works without a whole lot of trouble. And then we'll take a look at pushing copper geometry over into SolidWorks, so we can do real thermal analysis now with these tools. So let's take a look at that. Let's go back into our assembly here. And what we're going to look at is finding out that, well, gee whiz, we really can't get the configuration of motor that we really want. The only one we can actually get is this one that's got an extended shaft in the back for an encoder to go on. So now we've got this little problem here. So what we're going to do is we're going to create a cutout in the board. And go ahead and edit that guy. And we're just going to create another sketch here. We're going to use this shaft cutout here in the motor to make our cutout in the board here. Okay, so now we've got our board cut out. but we still got a little bit of a problem here. So what we're going to do is we're going to go back into our PC board assembly, and we're going to push this back over to PCB Works or SolidWorks PCB if you desire. Sorry, Dave. And then we're actually just going to pull that information out of the vault there. And then when we do, you can see we've got these design rule violations here. That's what the green color is. So we're going to have to take care of that. We'll just move everything out of the way here. Put it up over here in the corner until we clear our violation there. And again, we can go ahead and visualize that in 3D, make sure everything is where we think it needs to be, and then we can just take and push that back over again. All better now. So we can go back into our board assembly, pull this stuff out of the vault. Let's go ahead and select the changes, because I know they're right because I did them. No sense in reviewing them unless you're schizophrenic, and then you might want to do that. Okay, so now we've got our rebuilt PCB assembly. We can hop back over in SolidWorks. Oh, life is good. All right. So now what I'm going to do, now that we've got all that taken care of, I'm going to hop back into SolidWorks PCB, and I'm going to actually open up another circuit board where everything's already been routed. It doesn't have the cutout in it, but you can see we've got all the traces routed here. And what we're going to do is we're going to go up here and we're going to actually generate some copper information. I'm just going to put this in the same spot as I have the other parts. And the nice part about this is you can get rid of a lot of the detail in the 3D bodies. So if you know, a lot of times when we do simulation, we like to get rid of a lot of the detail so we can just generate simplified bodies here. I'm just going to leave the default here, and then I'm going to actually select to export all the copper. If you had a board with like thousands of vias in it, you probably want to not want to have those all exported, but I'm going to go ahead and, this is just a small design, so I'll go ahead and export everything for you here. And once we're done, we can hop back into SolidWorks, and we'll go ahead and open that file that we just generated. And we'll let that load up. Okay, so now to the casual observer, this might look a lot like the one we were just modifying there. However, it's not exactly the same. If we bring this up and we change the transparency on the board itself, oh, look at that. It's a thing of beauty. So now we can actually, and we've actually gotten our net names here. So if I want to take a look at the ground net here, I can do that. The motor for the supply for the motor here. And then the really nice thing is we're actually able to bring all the information from the vias and everything in here. So we have all of the barrel information in there. So now we can actually do some thermal analysis if we want. So that's enough to bring tears to your eyes. Okay, so let's just recap. So we generated the board outline in SolidWorks, pushed it over to SolidWorks Pcb. We took a look at the collaboration server there and how that works, did the system wiring, jumped back into SolidWorks, did the integration, and then at the end there, of course, we took a look at the design revisions and how the analysis options work, and I'm a little bit slow. I'm 5 or 10 minutes slow, but that's okay. Pretty close. All right. Let's get rid of that.